capacitor. So suppose this is capacitance, that is the conductor over there, so its capacitance is C and a charge is there on this Q. So what is the potential of this conductor? So potential is how much? Q by C. So now we are bringing a charge dq, a small charge dq from infinity to this place, infinity to this place. So what will be the energy stored? So energy stored is du, that is equal to q into dv. Yeah? So final point where it is infinity, so potential is 0 and this point potential is q by c. So potential of charge is increasing from infinity to q by c. So increase in potential energy is how much? So q into dv, that is dv is q by c into dq. So initially charge on this conductor was how much? So 0. Finally charge is q. So increase in total potential energy will be equal to how much? So from 0 to q. So 0 to q. So this is u, that is equal to how much? So q, c is constant, so integration will be q square by 2c. So 0 to q. So potential energy is how much? So formula is q square by 2c. So now we also know that q is equal to what? Cv. So we will substitute it over here. So q is equal to Cv in this. So this will be equal to c square v square divided by c. So that will be equal to how much? So half c v square. So that is the potential energy formula. So we have to remember this. So note point we will write. So where this energy is stored? This energy is stored where? So this is a conductor over here. So if we have supplied this charge q, so this energy will be stored where? So due to this charge there will be electric field generating in outside of the sphere. So electric field will be over here. So energy will be stored in the form of electric field only. So you can write down energy is stored in the form of electric field. So now what is energy density? So energy density is du divided by dv. So that is given by half epsilon naught epsilon r e square. So this is energy density. Already we have studied this topic in the electrostatics. So epsilon naught value also you know. So epsilon naught is how much? So 8.85 into 10 to the power how much? Minus 12 value. Epsilon r is known as the electric constant. So this is generally epsilon r is greater than 1. So that depends on the material. That depends on the medium material. So that is there. So now we will write down find final charge and heat loss during the redistribution of the charge. So this is the last question we will see. So initially this is one capacitor, on this charge is q1 and this is another capacitor, charge is q2. It is very large distance placed at the very large distance. So this is the switch. So find final charge when switch is closed. Charge on both spheres when switch is closed. When switch is closed. So now its radius will be given r1 and its radius will be given how much? r2. So after closing the switch we will assume that the final charge is q1 dash and q2 dash. So now total addition of charge will be how much? So same. So q1 dash plus q2 dash will be equal to how much? q1 plus q2. So charge will be, there will be no loss of the charge. So that is there. So after connecting this, so charge on this will be equal to how much? So potential will be same. q1 dash divided by q2 dash, that will be equal to how much? So दोनों का potential क्या हो जाएगा? Same. After connecting the switch, potential will be same. So that is why q1 dash will be equal to c1 by v and Q2 dash will be equal to how much? C2. Yeah, potential is same, so VB cancel. So ratio of charge Q1 by Q2 is this. So this is the second equation. So what is Q1 dash now? So Q1 dash we can write down in terms of Q2. So C1 by C2 into Q2 dash. So in first equation we will substitute this Q1 dash value. So that is C1 by C2 into Q2 dash plus Q2 dash. So that will be equal to how much? So Q1 plus Q2. So Q2 dash will be common. So C1 plus C2 divided by C2, that will be total charge over here. So that is how much? Q1 plus Q2. So from here you can get Q2 dash is total charge Q1 plus Q2 C2 divided by how much? C1 plus C2. So that is there. So similarly, what will be the value of Q1 dash? So Q1 dash will be equal to Q1 plus Q2 C1 divided by how much? C1 plus C2. So this is the value of Q1 dash. So in terms of if you want to calculate the final potential, V is how much? So suppose we want to write potential of the second capacitor. So potential will be equal to how much? So Q2 divided by C2. So that is there. So Q2 is how much? So from here we will write Q1 plus Q2 into C2 divided by how much? C1 plus C2. So divided by C2. So that is there. So total charge Q1 plus Q2 divided by C1 plus C2. So what is initial charge Q1? So initial charge Q1 is how much? So C1 V1 we can write, and initial charge Q2 how much we can write? So that is C2 V2 divided by C1 plus C2. So this is the final potential on the both of the capacitors final potential. So now suppose we want to write down how much heat is generated in the wire when charge was flowing. So heat generated in a wire while charge flow. So how you will calculate? So heat will be generated, so that will be equal to heat generated, we will write delta H. So that will be initial energy minus final energy. So initial energy is how much? So half C1 V1 square. Initial voltage is V1. So initial energy on the second will be equal to how much? Half C2 into V2 square minus final energy on both the capacitors. So that is how much? So half C1 into V square, and also minus half C2 into V square. So that will be equal to how much? So half C1 V1 square plus half C2 V2 square minus half. We will take common. So C1 plus C2 into V square. Already we have calculated the value of V. So C1 equals C1 plus C2 का whole square. So that is there. So half C1 V1 square. So half C2 V2 square minus C1 plus C2 will cancel. So that is half. So this will be equal to how much? So C1 V1 square C2 V2 square plus 2 C1 C2 V1 V2. So one C1 plus C2 will be over here. So we will take common half. Half will be common from everywhere. So C1 से इससे multiply करेंगे. So what will be there? So C1 square V1 square plus C2 will multiply. So C1 C2 V1 square plus we will apply multiply with this. So C1 C2 V2 square. C2 will multiply. So C2 square V2 square. So this is there minus C1 square V1 square minus C2 square V2 square minus 2 C1 C2 V1 V2. So this is there. So divided by C1 plus C2. So what will cancel? So C1 V1 square will cancel. Similarly C2 V2 square will cancel. दिले ना. So after solving this, so C1 C2 is everywhere, so we will take common C1 C2 divided by सभी से divided है C1 plus C2. So what will be there? So V1 square plus V2 square minus 2V1 V1. So delta H will be equal to how much? So half C1 C2 divided by C1 plus C2 V1 minus V2 whole square. So that is the delta H. So we can remember this formula. So this is very important formula. We should remember this. So okay, so for today's class we will keep up to now only. So complete.